Which one does that?
That's a different. You didn't have the 0 plus stipends one.
Cool.
I'm not giving it out. I will take it back. Just like you should read this.
Everything should be fine. There's loads of seats on this side, by the way, for anybody who wants to take a pew rather than being cool in the back.
I'm going to use the fine, really small font. Yeah, exactly.
Right, so it's 7, means that we're kicking off. Welcome everybody to Docker London! I mean, I'm not sure, who of you have been to the Docker London Christmas edition last year? Ah, okay, good. Because last year it was like completely over the top. So it's, I was kind of feeling bad, like, oh, maybe I should do it even more over the top, and maybe I should do more, bigger, better, and I just decided that maybe we should like go back to the core and just make it what it should be about, which is sharing some knowledge and hanging out with your friends. So, this is me. So for anyone who's been paying attention, a few months ago that said something different. Sorry, I'm a very needy person. I just changed jobs and I now do developer relations and community management at a company called Babylon. I do also lots of other stuff in the community, as you may know, like,
Run by Don.
this. I co-organized the Cloud Native London meetup. I am on the organizing committee for some other cool conferences, and I co-founded this thing called Meetup Mates. I will get you in a moment. So for tonight, I actually reinstated the Docker London Twitter account. I've been doing this for 2 years, and the Docker London the Twitter account was not mine. So basically that changed like 2 days ago, so I'm very happy with that. So expect some tweets, there's some hashtag Docker London as per usual. If you want to follow me, that's me. Shop. Cool, so tonight's sponsors are all of these lovely people, so I wanted to say thank you to Cloudflare for hosting us tonight, because I love this space. I'm pretty sure there's no one from Cloudflare actually here, are there?
Nope.
Oh yeah, yes, okay. Do you want to say something about the house rules or anything? So, the toilets are over there.
Exits are there.
Exits are over there. If the lights come off or something, don't follow the lights on the floor. There's no, no, never mind. I have been, is there anyone from Oracle here? Yes, yay. Oracle has been a very awesome sponsor for the last 2 years, and I really hope that's going to carry on next year. Would you like to come up and say something about Oracle Cloud?
I'll just say it from here.
Now, we're live streaming, so people at home also want to know.
So, hi everyone. So those people who think of Oracle as the dinosaur and think of Oracle as the kind of the company which doesn't get developers, well, we're kind of changing that, right? And we'd just like the opportunity to, just have a chat and change your mindset. We've got a lot of good things, a lot of cool stuff, and we've got our always free tier, which I'm happy to have a chat with you about later. Right.
Are we having technical issues?
Yeah, it's showing up here, but it's not streaming. No, here's that on flash screen.
Technical issues. Worked earlier.
Yeah, it worked earlier, but it's not working now. Did I restart this?
No. Probably restart the software. Anyway, so carrying on. Also, Technova has been a very awesome sponsor over the last 2 years.
I work for Technova. We're a digital consultancy. If you want to learn a bit more about us, come and grab me. More than happy to have a chat. There's a few of us here tonight. Also a proud member of Meetup Mates, which Megan will talk you through. But yeah, have a great night, guys.
Yay, Megan!
I got handed a mic, so naturally I was like, yeah, I'm coming up. Hi, I'm Megan. I'm part of the crew at Meetup Mates. Okay, it's on.
There it is.
Meetup Mates is a community initiative that is a pre-meet before the meetup, where you can come, have a beer, find new friends that are about to attend the meetup, so you don't have to arrive on your own. You can join at meetup-mates.com, and we have the Slack channel, so it's got a wide range of meetups, not just south of London.
Who's here for Meetup Mates, by the way?
Ooh, yeah.
Good, and obviously I wasn't able to attend the free meet, so I'm also quite curious who's actually here. Come on, give us a little eye. Come on.
Yeah. It's hard to
Come on, it's Christmas, you can shout.
Just oh. Yeah. So yeah, it was great to have you. Well, back to Dolly.
Thank you. Cool. Woo. Applause, yes, applause. So the other two sponsors that I would like to mention real quick is O'Reilly and JetBrains. Did anybody see the news about O'Reilly buying Katakoda? That's pretty cool, isn't it? Anyway, O'Reilly's been a really awesome sponsor of us as well. They've also, over the last year or something, they've been giving us books and like swag and all that kind of stuff. So we have, for the Christmas raffle, our annual Christmas raffle, we have a bunch of books. It's there on the suitcase. The suitcase is not part of the raffle, but just saying, this is how I'm trying to take all this stuff back home. We've got some books here. Using Docker, Docker up and running, programming Kubernetes patterns, and the Docker cookbook. So, we'll be raffling all of these books. So if you have your tickets, not now, we're doing it in a beer break, but make sure you keep your ticket. You have the opportunity to win something tonight, and our lovely assistants, Christmas people in the back are going to be helping us out with that tonight. JetBrains has kindly offered us 3 one-year licenses to any of their IDEs, so we'll be raffling a few of those as well. So IntelliJ or PyCharm or GoLand, I think, all that kind of stuff you can use that for free for a year, which is pretty cool. And yeah, okay, so that's this slide. A few community updates. The next, okay, so the Docker London video channel will be where all the videos live, obviously. So we've been recording and live streaming for the last year, so there should be some interesting sessions on there. Please bear in mind, I also have to edit everything myself, so it's some of them are not cut yet, so trying to sort that out. The next Docker London will be in January, on the 23rd, I think. Other community updates happening tomorrow. There are loads of meetups, but 2 noteworthy ones is the Kubernetes meetup at Monzo and DevOps Exchange at 2 locations this time, which is funny. And then the other 3 noteworthy things are Cloud Native London on the 10th, Microservices on the 11th, and London DevOps on the 12th, which is going to be a very interesting week. I'm looking forward to that. Okay, so basically, this was when you were supposed to say stuff about Meetup Mates. There is a slide. No, it's fine. I mean, this is, first time. Okay, no, there's a specific slide. So, if you didn't catch it when Megan said so, please follow us on Twitter and go to the website to register. I made this slide. Okay, so. Anyway.
So good it's first come up
Right, so the agenda for the evening, we will be starting off with Karthik from Tigera. Tigera, okay, sorry, I'm just making sure everything's... who has also been so kind to offer us a PlayStation for the raffle. So funny story, I was at Microsoft Ignite a few weeks ago in Florida, and I ran into one of his colleagues at one of their stands, and they're like, oh, yeah, so make sure that there's a gift to raffle. And I was expecting, like, I don't know, something small. It's like, oh yeah, it's the PlayStation, all right? I said, yes. so thank you so much for putting it up for the raffle. Second up, we have our good old friend Fernando, who's been a very active part of the community in general, but I don't think I've ever seen you speak. So, this is an exclusive, so you can now all bombard him with questions the way he does that to other people. So, briefly so. And then we have a beer break and the Christmas raffle. So, who was here last year may have seen that our good friend Ivan had a Christmas suit on, but this year I've been a bit busy, and we thought that maybe we should do a little less is more, so we have a Santa hat, and that's what we have to do with because it's about the prize, it's not the way it looks. And then last up we'll have my friend Victor, who's also my neighbor, talking about MTLS and some other stuff. And after that we're going to the pub. Now, can I ask anyone in the back who is not, like, have we got a pub selected? Does everybody like All Bar One? Anybody in favor of All Bar One? Okay, we're going to All Bar One after this. Follow anyone from Technova with a Technova t-shirt. They may or may not have, you know. Alright, so give it up to Karthik, and we'll be starting right now. Sorry?
Yeah, it's lagging.
Is laggy?
Lagging is okay.
Well, it's
Lagging
like
is normal.
like 30 seconds behind.
That's okay.
Yeah, but that's just the internet connection.
Do you have any comments about candidates? Because people Okay, is this audio okay? Mic is there. Perfect. Thank you guys. I actually don't live in London, I live in San Francisco. So I think it's the first time I'm doing a meetup talk in London. So nothing like driving a new meetup audience with a PlayStation, right? So Christmas. Yeah. So thank you guys, and look, I'm actually looking forward to this conversation. A little bit of a quick intro about Tigera. How many of you have heard of Calico? Nice, good. And for the rest of you, hopefully by the end of today, you want to go back and let me try this out, right? So Calico comes by default with most of the Kubernetes platforms today. The reason for that is we've actually worked upstream in Kubernetes around building the abstractions for things like networking and or network policy. So when you look at things like CNI, Tigera's the Calico teams being the co-maintainers of CNI. Calico, which is our flagship project, has integrated very deeply into Kubernetes and also with other platforms like, by the way, when I say Istio, Envoy, you guys know what I'm talking about, right? Yeah, okay, good. With some of these platforms to provide a much more cloud native way of doing things like networking and more specifically network security. But today, if you deploy Kubernetes from any of the major hosted cloud platforms, EKS, AKS, GKE, IBM Cloud, all of them bundle Calico out of the box by default. And that's also true of all the major distributions. It comes built into Docker Enterprise. Unfortunately, we were going to focus on the Docker Community Edition, where you have to build your own Kubernetes along with UCP. But that said, Docker Enterprise, which as of a week and a half ago is now Mirantis. How many of you guys are using Docker Enterprise? How many of you guys are on Docker Swarm, just out of curiosity? Okay, great, there's a couple of folks. So it sounds like this is a bit of a Kubernetes crowd. There's a bunch of people nodding their heads on Kubernetes, which is, that's the market where we are today. And so typically when you look at Rancher, you look at obviously Docker, you look at OpenShift, you look at D2IQ, Canonical, all of these guys bundle Calico out of the box. In fact, I think it's a default in pretty much everything except for OpenShift. Right? And it's the same in the on-premise distribution like GKE on-prem, AWS, of course, various other platforms also work with Calico and provide Calico out of the box. That said, what Tigera as a company does with Calico is help customers adopt Calico for more advanced network security controls. And today, I usually start with some anecdotes, right? But you can pull out your wallets, and today any major, if you look at the plastic that's in your wallet, chances are the applications that are protecting that plastic are being protected using Calico. They're being networked using Calico. You pull out things like your devices, chances are those devices are leveraging Calico for the networking and network security across tens of thousands of nodes. So generally, and you can go even further, you can look at the applications which are running on those devices. Chances are the SaaS companies delivering those applications are using Calico and Kubernetes for the networking and network security. You look at the games that you're running, games you might be running on this platform, in fact, including the platform itself. All of them are using Kubernetes with Calico to provide the connectivity and the network security, right? So pretty widely deployed, but what does that mean? And one of the reasons why I like to do a little bit more of a deep dive into security is to educate the market about some of how you secure your workloads in these dynamic Docker/Kubernetes platforms. But the other reason I do that is to sort of get the word out, because we are also hiring like crazy. So if you want to come work and help some of these organizations adopt Kubernetes at scale, come talk to us. Specifically, Tigera as a company is now growing into Europe. So we are hiring I'm specifically hiring solution engineers. We're hiring salespeople, we're hiring engineers, so generally come talk to me afterward if you're interested. Anyway, so let's get to sort of the meat of the talk, right? So how many of you, show of hands, how many of you guys actually have workloads running on a Kubernetes platform? And keep your hands up. How many of you feel like you just got some basic security and then it's not going to be enough? How many of you have actual, let's call it, some sort of zero trust networking? And by the way, if you haven't read this book, go buy this book, read it. It's a great book to read called Zero Trust Networks, which is ultimately the concept of every workflow between any pair of microservices, any pair of applications. Both sides of the application use some form of identity to authenticate who the remote side is, and to obviously encrypt as well, but to make sure that all communication flows between any pair of services is authenticated and also authorized. So there's a concept of identity, there's a concept, and identity could mean different things. It could mean IP address, it could mean external client certificate, it could mean, it could be a JUT token or JUT. But then how do you authenticate who you're talking to? And then when you're receiving a connection over the network, is that connection actually something that you want to authorize? i.e., is that a valid thing? And then following up from that connection, being able to go back and audit what exactly happened. And all of these are fundamental concepts of what go into a zero trust network posture, because as we all know, every day there is a new breach of some kind. You don't want to be on the receiving end of that, right? So if you haven't already taken care of that, you may want to go read this book and start internalizing some of the principles around zero trust networking. And the Tigera team, the Calico team is heavily focused on what this means from a networking perspective. So if it's bits on the wire, we should be able to protect it. Specifically, we're going to focus in on Kubernetes and Docker today, but it could be just as valid for any pair of services. And I know this is talking to a little bit of a jaded audience, so using terms like manifesto is probably not a good idea in this area or in this time of year, at least for another couple of weeks. But to give you a quick snapshot of what Calico brings to the table, first of all, Calico is obviously open source, and obviously comes built with the platforms. So to use Calico on any of the major platforms, all you have to do is use it. You don't have to do anything beyond just start using it. But specifically, Calico brings this concept of policy as code, which is ultimately you declare your primitives for isolating workloads from each other and the authorization primitives in typically a YAML format. Run it through the same set of CI/CD processes as your application. And also, one of the things that Calico helped bring to this space is the fact that your isolation controls, your microsegmentation, your firewalling is all very dynamic, in lockstep with the orchestrator. The reason it matters is if you are deploying workloads on Kubernetes, your workloads are very dynamic and transient, your pods are dynamic and transient. If you're deploying a service mesh, you could have 10% of your traffic go this way, 90% go a different way, and all of this is changing all the time. So if you're relying on perimeter security controls, those controls don't understand the orchestrators, and this is why the need is for a much more dynamic and adaptable set of security controls that change in lockstep with your workloads as provisioned by your orchestrator, Kubernetes, your service mesh technology. The third element is that Calico implements its policy enforcement historically at the pod virtual Ethernet in Kubernetes, so at the egress from the pod. We'll talk about this in the demo, we'll show this in the demo, which is ultimately Calico can also protect the hosts themselves, including the Kubernetes control plane. But a couple of years ago, the Calico team worked upstream with the Envoy upstream community to build the authorization filters in the Envoy proxy. Anyone here not familiar with Envoy? Okay, so if you're not, please go back and read up on things like service meshes. I'm not going to introduce Envoy here. Ultimately, the concept here is you have a sidecar proxy next to your application container inside a Kubernetes pod that is doing some of the heavy lifting around traffic management and so on. And Calico provides this concept of a unified policy model that is being enforced at various points. Inside the pod, leveraging Envoy, at the pod virtual Ethernet, outside of the pod's namespace, network namespace, at the host interface, and potentially outside the host as well. And finally, a couple of years ago, in lockstep with that investment in Envoy upstream, which we have since we built the external authorization filters in Envoy, we also extended the Calico policy model to not just do network policy, as in Kubernetes, but to extend into the application. So providing the ability to specify things like I want to allow HTTP GET, but not a put, if you're dealing with an application where there's no reason to have a put, right? So being able to have a unified policy model, providing policy instantiation dynamically at various points for defense and depth, right? So that's in a nutshell what Calico brings to the table. And ultimately, all of this is being managed in lockstep with the applications. So for those of you who build applications and deploy it, I've talked to a few of you, in fact, some of you work with some of our customers. This is managed the same way as you would manage your applications. Managed in some sort of a codified format, managed via CI/CD, with additional controls for security, right? So as your workloads shift around, as your workloads go from on-premise to a cloud, as your workloads get, as you get canary versions, your security controls follow your workload wherever they go. So that's in a nutshell what Calico does. And this is fundamentally the model that has been adopted by Kubernetes. We worked upstream in Kubernetes 2+ years ago to make this the standard. And for that matter, when you look at service meshes like Envoy and Istio and so on. And very briefly, I think I'm going to focus the time here on a demo, because I think the demo is always more compelling rather than walking through a bunch of slides. But very briefly, for those of you who like reading YAML and writing YAML by hand, that's what a typical Kubernetes network policy resource looks like, which is what you do is you put a workload in the default deny and then say, I want to allow traffic from this other label or workloads with this label using TCP port 443. Or, you basically allow specific TCP or UDP flows. Or in the more recent past, Kubernetes has also allowed CIDRs, random CIDRs, or you can also specify things like SCTP. But that's the limit of what you can do with Kubernetes. Calico, being the best implementation in network policy, implements all of that, but also provides a lot more features. It's a much more feature-rich implementation, and specifically with a lot more advanced capabilities. So being able to support actions beyond just allow. So being able to say, maybe I want to deny, maybe I want to log traffic, maybe I want to do other actions. Being able to do more complex expressions, being able to prioritize your policies in terms of what sequence your policies apply to your traffic. Doing more advanced sort of flows. And again, the concept is, as Kubernetes, as your service mesh dynamically orchestrates your workloads across one or more clusters, these labels and workloads, as they come and go, Calico dynamically creates those microsegmentation rules, right? And again, with some of the more advanced constructs here. And like I said, 2 years ago, we extended it to also supporting, I noticed that what I'm seeing on my laptop is not what I'm seeing on the screen here. There should be a little highlighted section, which is kind of a little bit.
It's highlighted.
Yeah, it's fine. I think it's fine.
It's highlighted.
Just a little bit. Okay. Wasn't very visible to me, so that's why I was like, I had to really. But yeah, I think you can see it, right? It's fine now. Yeah. It's totally fine. It just came out really faintly. So a couple of years ago, we worked with the Envoy team to extend first build the authorization filters in Envoy, and then extend the Calico policy model to also support layer 7. So you no longer have to have a set of network firewalls and a set of WAFs. And for those of you who maintain multiple firewalls in production, you always have them in sync all the time, right? Exactly. So it's one unified policy model, but being enforced at various points. At Envoy, at the Kubernetes virtual Ethernet, and at the host. Anyway, that's a quick overview of the policy model. So let me start with a quick demo. How much time do I have, by the way? Okay, good. So just to illustrate the demo and what happens here, I'm going to use a sample application, a handful of microservices. what it is have a customer microservice that is internet facing. Let's call it it's a banking application, right? For those of you who are going to be going out to Monzo tomorrow, Monzo is a terrific Calico user. They've written up a wonderful blog post about how they use Calico to secure the workloads. So Google join that, right? I'm going to pick a synthetic application. This is not a real world, although I know a number of customers in similar sort of deployments. You have a customer front-end application where you log into it and you can see your bank balance. And that customer microservice is talking to a set of application logic, which is doing the processing. The application logic reaches out to a database, right? So that's a sample application. And what we're going to do is, and by the way, I have this deployed on a simple 3-node cluster. I spun up a few hours ago, or a day ago actually. And we're going to launch a number of attacks on this. And what we're going to show you is a little bit of how you may want to leverage policy in Kubernetes and a service mesh and Envoy and Istio to be able to protect against some of these attacks, right? And by the way, this is just a small sampling. There's a lot more advanced attacks in the wild these days, and we've been tracking a number of them, right? So this is a constant something that's changing constantly. And to begin with, the first couple of attacks I'm going to launch are going to be, since this customer application is going to be facing the internet, chances are your developer that's built that application has packaged in some vulnerabilities. It could be in some of the container layers that are built in. It could be in something the application itself does. So first thing you're going to do is you're going to attack that application, assume that's taken over, and then one attack is use that compromised pod to directly attack the database. The second attack we're going to do is a little bit more advanced, because what we're going to do here is, assuming you compromise the customer application or you compromise a microservice, perhaps that microservice has a X519 certificate assigned to it. For those of you who are familiar with how Kubernetes and service meshes work, typically that is done using a standard called SPIFFE. The Tidera team is actually one of the co-maintainers of the SPIFFE specification. And ultimately, you assign an X519 certificate to service accounts for a given service or a given deployment. And given that that certificate is running in the pod namespace, something like Envoy has that certificate, there's no reason why the attacker couldn't get that certificate and now pretend to be whoever that certificate allows him to be. So now we're going to actually launch a more advanced attack where we're going to actually take that certificate and launch an attack against the database, right? So, to begin with, let's take you to my cluster. If I show you my pods which are running, there's my handful of pods which are running. And let's go launch some of these attacks here. So, first thing I'm going to do is launch an attack pod, and I always forget the command, so I'm going to go do this. So first I'm going to log into the customer pod. I'm going to assume that's already been hacked, right? So it's already been exploited. And I'm going to launch some attacks from it. So first attack I'm going to launch is I'm going to try and target the database directly.
Is this readable for everyone?
Yeah? Okay. And when by the way, I have these pods running, right? So if I go to my actual front-end application, there's my application. I've logged in. I'm seeing my bank balance. So I don't have very much, but you know. Now I'm going to go take this pod and try and talk to the database directly. And when I do, you notice that I'm not just seeing my account, I'm now seeing everyone's account. So, because I bypassed the summary pod, and I'm going to assume a lazy developer. For those of you who are developers, my apologies, but a lot of developers attempt to be lazy. What's the quickest way to get something done, right? And, sorry. So that's one attack. And now the second attack I'm going to launch is a little bit more advanced. So I'm going to, since I launched that attack pod, let me figure out what that attack pod is. And I'm also going to exec into it. And now I'm going to try and actually do a post to the database. Oops, sorry about the. Fair enough. Anyway, you saw me do a put. So if I go back to my balance now, notice that's gone up, which is very nice for me, right? So now, how do you protect this? The way you do this, you can do it in a variety of ways, and obviously I'm going to show you the Calico way of doing things, is I'll show you what this policy looks like in a second. Oh, sorry. And since this is Calico, I will do this by Calico Petal. And kubectl, you can use kubectl with Calico objects, but it's typically intended for users and developers. CalicoCutl is a more administrative command that has more advanced functions. And to show you what this is doing, essentially what I have in this policy is a policy that applies to anything with the label app equals database. As database pods come and go, I'm only going to allow traffic from service accounts labeled summary, and I'm only going to allow a HTTP GET. The reason we're using a service account label in policy, or service account name in policy, is because you have more advanced RBAC controls in Kubernetes that you couldn't do with pod names or pod labels. So now if I go back and launch the same attacks I did, okay, let's try changing the value again. I'm going to add another 0 perhaps. And notice that time's out. And through the customer pod, I'm going to try and let me exit out of this and go to the customer pod. I should have just done Control R. All right, there we go. And I'm going to try and talk to the database directly. And that failed because I get a forbidden. Right, so that was fairly straightforward. You could have done this a variety of ways. I showed this with Calico, which integrates with Envoy behind the scenes. It integrates with Kubernetes, it provides the implementation of Kubernetes separate policy. But you could have just as easily done this with something like Istio. If you have Istio deployed across all your workloads, not everyone does. You know, today Istio is still sort of getting to the, I think there's a lot of people still getting to production scale with Istio right now, but you know, it's very promising. Now, that's all great. So what we've shown is, in effect, we protected these two attacks. But that may not be all of it, and there might be other things that might be going on. Now, you have this attack compromised pod here, and there's a whole bunch of other attacks that the attacker might run, and let's run through a few ways that we can lock down the cluster to prevent some of those. So, I'm going to start with one here, which is I'm going to do a as a cluster operator, I'm now going to say, look, I'm not going to trust my developers. I'm going to make the default posture in my cluster default deny. So if you are a developer, you will need to build a fine-grained policy. And what that is a very simple Calico resource that says, I'm going to do a default deny. So if you are a developer, you better write a fine-grained policy. And along with that, I'm going to allow the control planes, which is in effect, what I've done is I've allowed the kube system and the Istio system namespace so I can talk to them, talk to DNS as well. So now if I go back to the customer pod, I can do a dig on something like google.com, and that's going to my core DNS, which is running inside my cluster. But if I do that same thing on something like 8.8, that's going to time out. So I'm saying on league authorized DNS servers. And I'm also going to say something like, you better define your fine-grained policy. So let's go a little bit further. So now my developer wakes up and says, I'm going to define a fine-grained policy. So if the developer says kubectl apply, so for my little Yao Bank application, the developer has created a policy that says I'm going to now allow my summary to talk to the database. I'm going to allow my database to talk to my customer. I'm opening it up on port 80 and 443. So now if I go back to my application, that should hopefully still work. There you go. So that application is still accessible. But if you look at the policy, one of the things I've messed up as a developer is this egress control. As a developer, I've said, I don't care to protect my applications. I now need to do this, but I'm going to allow it to talk to the rest of the world. Do your pods really need to talk to the rest of the world? And a common attack vector is going data exfiltration, talking to command and control systems, right? So for that, we are going to take it one level further. So we'll do a egress lockdown, which means now if I go back, and what that is saying I will again allow you to egress from pods that have the service account label internet egress equals allowed, i.e. as an administrator, as an operator, I need to go and say, you want access, I'm going to give you access, but I'm not going to give access to everyone else. So if I go back and run the same command from the pod, let's try and ping, that's going to fail. And if I do a kubectl label, actually I'm going to do the label service account, which I'm doing as an operator. And this is in the Yao Bank namespace. And now if I go back and run that ping again, oops, sorry, do that. And if I go back and do that ping, now that I've labeled, what did I mess up? Service account, customer.
Egress? Typo somewhere?
It's possibly a typo somewhere. Anyway, I assume it works. Sometimes the demo guys are not friendly, but trust me, it works. I'm pretty. All right. Now that's all great. One last thing I'm going to show you is I'm going to go to, so I've protected my application. I'm giving only egress to certain applications. That's great, but what about what else have I left exposed? This cluster I deployed using kubeadm. I'm going to log into a random cloud instance running in the same cloud as my Kubernetes cluster, and I'm going to try and curl the etcd for the Kubernetes that got deployed by kubeadm. Guess what? That's open. You left your Kubernetes control plane open. Not a good idea again. So, a couple of quick things you can do is I'm going to apply something to lock down the host interfaces. So I lock down, and I'm going to also do and what this is Calico can also protect the host interfaces using labels as well. So you can now have dynamic policy that follows your Kubernetes control plane as well. And what my policies are saying is I'm going to allow on the master nodes etcd access only from other master nodes. I'm going to allow worker nodes to only have things like kubelet running. I'm also locking down things like node ports. So one quick artifact of that is now if I go back to my application, suddenly because I locked down my host, let me do this, it says it's got contract. That should time out because suddenly I've locked down my node ports. And Calico does have some advanced features which is to allow node ports as well. So specifically, I've got a handful of node ports in this case for things like STA gateway and a few other things which I'm allowing through. So now if I go back, guess what? My app's working again. And so ultimately, what really happened there is not only did we protect the different attacks within the cluster, we provided exfiltration outside the cluster, we protected the control plane for Kubernetes, we also protect host-bound services, including node ports. It could be for standalone cloud instances. Ultimately, what you're getting to is a dynamic policy that follows your workload, irrespective of whether it's running in Kubernetes, whether it's running outside, whether it's running on whatever cloud platform you want. And all of this is managed in a dynamic policy sense where your firewall rules come and go following your workload. These are not things that get left behind. So the takeaways are, if you're not building security controls for your workloads in a dynamic manner in the same way that your applications have evolved to microservices, you may want to keep an eye out for the latest breach report because you might be one of them. Please do go join the Monzo meetup tomorrow. They've written up some wonderful blog posts of how they use Calico for network security. Irrespective of how you use the underlying technology, this is something that you do want to think about. And last thought is, we are hiring. If you want to help people think through these sorts of concepts, come talk to me. We are getting some incredible growth in the market, really high profile organizations, like I said, so would love to talk to you if you're interested. So that's it. Any questions, or we can do questions, I'll be around later.
All right. So, are there any questions? I will come to you with a microphone.
Are these policies readily available to clients, or are they custom made by your team to the clients?
Yeah, these policies are typically built by whoever, right? Tigera is not a very large company. There's a some other consulting we help clients with developing this. Tigera also has a commercial product called Calico Enterprise, where what we can do is we can auto-generate the policies by looking at actual network traffic flows and provide recommendations, put those policies into permissive mode so that actually it's something where you can see what the impact of it is, and once you're satisfied, start enforcing. But that's on the commercial side, and that, as Tigera, that's one of the ways we make money. But the policies themselves, if you like building YAML by hand, go for it. If not, come talk to us as well. Thank you.
Any other questions?
Thanks. I'll be around after as well. Thank you, guys.
Thank you. All right. Up next is Fernand. So while we're here, I normally forget this, but I kind of want a selfie with everyone. So everybody in the back in the kitchen who's like chatting away, I'm talking to you. Get in here for a selfie. I'm gonna have to try to this is. Okay. I'm gonna stand over here, and I'll do it from the other side as well. See what comes out the best. Alright, say hey! That was very mild for the first time. Okay, one from the other side. I mean, stuff. All the things.
Yay!
Right. Show of hands, everybody say yay! Thank you. Have you been given the mic?
That one?
No, well, right.
I can use that one.
No, you have to do a demo, right?
No, demo is true.
Okay. All right. Well, give a warm applause to Fernand. Say stuff.
Stuff.
Have you pushed the button?
No. There's a button.
There's a button on the front.
Yes, stuff.
Woo!
For those that don't know me yet, I'm Fran Gell. I work at SRE. I contribute to the several open source projects, among them Moby Build Kit and Docker Build X, which I'll be covering today. You can find me on social media.
You on social media?
Yay. On Twitter, on LinkedIn, I have an extensive Git repo with a bunch of examples of the stuff we're covering today. And you can also find me on Docker Community Slack, where plenty of nice stuff happens. Show of hands, how many of you build Docker images? Okay, I would expect so more. How many of you know exactly how a Docker engine works, the Docker build engine works? Okay. Okay, this is gonna be fun. Do you guys know that for the Docker build engine is 6 years old? And in that time, there's only been one major change done to it, which was adding build stages, multi-stage build support, and that was on Docker 1705. So that was already 2 years ago. And since then, developers and users kept asking for more features, but the build engine is so complex that nothing has been added since then. So what the Docker engineers did was introduce a new thing called BuildKit, which brings me here today. So BuildKit, BuildKit is an entire new code base to replace in the future the current existing Docker build engine. For those that are still new to Docker, there's one first video there done by Sebastian and Tibor about how to build good Docker files. And for those that are regular to this meetup, you have seen probably a few meetups already where people come here and show you how to build good Docker files. So that's a good first video for those that want to introduce and improve their Docker files. On the second video, we've got Tibor, the maintainer of BuildKit, and he shows you way better stuff than I'm going to be able to demo today. And he shows you a very interesting feature, which is output artifacts from Docker file build. So imagine that you want just not to run a Docker, but the result of what a Docker can build for you and produce an artifact with that. This is some of the amazing features of BuildKit, and that video shows a good example of this. So, who can tell me what BuildKit is? Anyone? Yeah, I'm going to try. So BuildKit is a low-level build definition format called LLB. This is an intermediary image format that then creates the final format that's used by BuildKit. BuildKit itself doesn't know anything about what the front end is, or even what an output of it, what the result is, just the middleware there. And developers can produce their own front ends to BuildKit. So this is very low level, again, LLB, very complex. One of the front ends that most people use these days is Dockerfile v0, which is the front end for the existing Dockerfile format. Some of the key features of BuildKit, I have some there. The concurrency, dependency, and resolution. So these, some of you, like myself, build Docker files with many multi-stages, and sometimes you don't need all of them. You need probably some intermediary and some final stages. What BuildKit is able to do is it knows what output is going to be, so if there's multi-stages that you don't need, it just skips them. So if you have 10 multi-stages, you want to build your test, you want to build your UAT image, you want to build your production image, you want to build your dev tooling image, and you don't need all of them, you just need one now, BuildKit produces only one output. Doesn't go over the entire Docker file. Doesn't build all of those stages. Faster, better for everyone. Efficiency instruction crashing. For those that have been building very long, very extensive Docker file images, you know that if you change the order of some commands, the cache bursts, and but I still need that in the top, but it's not actually in the best place for it. BuildKit it builds a graph of the entire Docker file, so it's able to ignore the order it's there and uses the fastest, best way to build the image, the final image. So again, faster for everyone, not need to worry so much about your Docker file, better process. Another feature I love is the build cache import and export. I was talking earlier, where is it? Somewhere around. I was talking earlier to someone that we talked last month here, how this is beneficial for everyone. You can cache your intermediary layers and push those to a registry. Later, when you're going to build again, it will pull only the layers you need and build from there. So you might skip all those stages to build because you already built them before. You've got those on a registry. Cool? Nice features? Everyone likes this? Who use cache today? Nobody. Nobody wants cache. Why? Another great feature is distributed workers, so you can have multi-nodes that are building the images for you, controlled by a single control plane, and execution without root. So this is great for people that use Kubernetes or Docker in Docker. You can have rootless images support. With all these things, all these nice things that we had there, some of you might say, why are we not using BuildKit today? Why isn't everyone using BuildKit? Okay, so BuildKit comes with Docker 1809, but it's comes disabled by default. It comes disabled by default because it still doesn't support Windows containers. Not sure how many of you are building Windows containers these days. I am, sadly. It's actually not that bad. But yes, it's not supported yet, so by default it's disabled. So to enable, all we have to do is, oh sorry, wrong slide. You should have expected that one. To enable BuildKit on 1809 or newer, all you have to do is export Docker BuildKit 1. Okay, keep this in your eyes, burn this into your eyeballs. It will be enabled for you all today. To enable this on Docker Compose, recently released version 125 came out last week. All you need to do is export Docker BuildKit 1, the same for BuildKit, and export Docker Compose or Docker CLI build 1. And this enables it on Docker Compose. So, for the only thing I want for you to take out of tonight's meetup, and that includes the beer, is that you go. No. It's that you go back to your computer and you enable BuildKit. Okay? It's that you guys go to work, you go to your CI, and you enable BuildKit. Come on. Repeat after me. Come on, everyone. Export Docker BuildKit 1. Again. Okay, there's a test after this. So, as I said before, BuildKit produces these front ends to generate the intermediary images. And this allows for anyone to produce their own format and front end for BuildKit. And the team behind BuildKit introduced a new one called experimental syntaxes. And one day, some of these will end up in the standard Dockerfile format. You can find on that first link some of them. I'll be covering some examples in a bit. And all you have to do to enable this experimental syntax is add this line, syntax Dockerfile experimental, and you can have also a version pinned to it, to your Dockerfile. The first line of your Dockerfile. Not from, not arg, that. It's as simple as that, and all of a sudden your Dockerfile is better. That and export BuildKit. So one of the things many people have said to me, and you've probably seen plenty of people say this on Slack, is that, oh, I cannot use experimental things on my production containers. Nah, I'm not going to put it in production. The thing is, they are considered experimental because they are not part of the standard Dockerfile format yet. They are considered experimental because we as a team within Docker are still experimenting. There is more features, changing them sometimes. And yeah, that could break your environments. So what you can do, if you want to introduce this to your production systems, you can ping the version we release. So that's the latest. Or you can ping the version you want, and that's going to be the one you use forever. We don't change the current existing version, we introduce new versions. And eventually, when we believe this is a stable thing, some of these features will come up within the Docker standard format. And here's an example. I'm going to show you a bit more on this. So, let me clear my mouse. Some of these experimental syntaxes are the random mount type, and you can mount binds, you can mount cache, you can mount secrets, and this brings huge benefits for everyone that's building Docker files today. The mount type cache allows for the builder to cache packages, downloads, that means stuff from npm, Maven, APK, APT. These are no longer stored inside the Docker file layer cache, they're stored on your host. So the next, later in the Docker file, on another build, on another layer, or in the following build stage, can use that cache. That's on your host. You no longer need to download everything again from the internet. You already downloaded it once. There's no need to download everything else, unless you're doing all even more. There's also the mount type secret. Whoever had the need to put SSH keys or AWS credential keys, so your Docker file build needs access to something, now that no longer goes inside your Docker file. That no longer goes baked in your Docker file. You mount that, and that stage, that run, that single line is the only that have access to this secret. Outside of that scope, no longer has access to the secrets. See if this works. Okay. I have a few more examples on this page, which I cannot see from my laptop. I've built many of these examples for many frameworks. So for anyone that's interested and that uses any of these frameworks, it's just copy paste this and you've got your work done. Now I'm going to talk about a third topic that brings us tonight, which is BuildX. So far I've talked about BuildKit, and BuildKit is just that middleware, just what stuff builds in the engine. And if any of you, not I raise your hand when I ask people to use BuildKit, knows anything about BuildKit, it's incredibly a new language that you need to learn. It's an entire new process to build images. You need to build your Docker file, front-end Docker files for this. So it's hard. It's very hard for any of us. If you ask me, I probably have to go look at documentation to do one now. There's a steep learning curve. So in order to make this much easier and accessible for everyone else, the Docker team introduced a new product called Docker BuildX. So BuildX is a Docker CLI plugin, and it works at a drop-in replacement. You put it in place, and it will replace your Docker build command. It's the same UI, just fits there, you put it there, and now all the commands that you used before for Docker build, you can use Docker BuildX build, and straight away it goes there. So BuildX already comes bundled with Docker 1903 or newer versions, but still requires for the experimental mode to be enabled. It has the same commands as Docker build. If you look at the manual, they are exactly the same. It's parity 1-to-1 with Docker build commands. And it can be used with some limited capabilities of BuildKit if you use it in the Docker drive mode. If you use it with the container driver, you have full ability to use all the features that BuildKit gives you. Okay. BuildX supports multiple builders, so you can have an array of builders doing the build for you. And it supports cross-platform images, so you can have ARM, you can have CAXX, you can have Mac builds, all from the same interface. And it supports Docker Compose YAML, so if you already have all your stuff built in Docker Compose like I do, you can just use it straight away. Or you can use HCL or everyone's favorite, JSON. So, to enable BuildX, all you have to do is add experimental enable to your Docker config JSON. Or you can do it inline. Or you can use the environment variable Docker CLI experimental equal enable. If you are on an older system that doesn't have BuildX bundled with it, so before 1903, you can download and put it inside the Docker CLI plugins. Or if you want a newer version than the one that comes bundled with 1903, there's already been 3 releases after that. And the moment you put it there, you no longer need to enable it with the flag, because it's now a plugin, it's not using the bundled version. From BuildX, the most interesting feature that it provides you is bake. It's probably was the first thing that attracted me to using BuildX was this bake command. Use it as docker buildx bake -f and the file that you want to build, like a Docker Compose file. And one of the things it allows you to do is the concurrency building of all your services. So if you have 10, 50, 100 services on your Docker Compose file, you issue a single command and it will distribute all that work over your own builders and build all of them at the same time. This is the official page from Docker for Bake, for BuildX, and you can see all the commands for Bake there. I recommend reading this. You're gonna love once you start using more of this. For me, the best benefit of this is that it's so easy to port all the stuff I have on Docker Compose into Bake. May the demo gods be with us. I was testing this earlier, and Cloudflare network is much faster than my network at home.
We are Cloudflare.
Yeah, it's weird. I wasn't expecting it to be so fast, so my demo might not be as realistic as I wanted. I'm going to show you 3 ways of building, so the very old one, standard one, that everyone can use, Docker Compose. Version 125, no features are enabled, so you can see build kit is disabled there. I'm clearing all my cache there, just make sure there's no artifacts on it. Takes about a minute. It's slow. Come on.
I mean, I suppose we could do it back in the week.
Yeah. Okay, fine. Okay, so it's starting the build process of Docker Compose. So I have a few images there. I'm building Node, PHP, a few others. Okay, you can see that it took about 7 seconds. Yeah, sorry. About 7 seconds to build this. Hopefully the demo gods will not screw me up now. So using the same Docker Compose file, same configuration, I'm enabling build kit and build kit CLI build for Docker Compose. Okay. I'm also enabling Docker Compose parallel for those curious about that. You can see the interface is now totally different from what you used from Docker Compose or from Docker's build. And this process took 5 seconds and a half. So slightly faster than the one using the Docker Compose. And now, for my misery, I'm using Bake in here instead of using Docker build. Hopefully this will be interesting to show you. By the way, you can see here the 2 formats. So you have the YAML format of the Docker Compose, of the images I'm going to build. So in this case, an Nginx and a PHP image. And if you use Bake, you can output it, and the default format is JSON. So you can see the format here. And the process took the same 5 seconds, slightly longer. And you can see that all the images have been built so far. Okay. Where's my slides? So, if there's anything I want you guys to take home from today is, come on. You go home, you go to the other CI to work tomorrow, and come on, there's pizza waiting. All right, on my slides, there's a few links for this, both for the history of BuildKit, how it was started, the entire discussion of how it should be, the BuildX stuff, my examples on BuildKit, and the 2 videos I linked before. Thank you. Any questions? It's your time to screw me now.
Does anybody have any questions? I will be running towards you with the microphone. Okay, I'm just gonna go for the easy way. I'll come over that way. Sure.
How different is this with the tools like Builder?
Multi-stage.
Is it a different one or like Builder or Partner?
So this is still your plain Docker engine, right? So BuildKit is it's a replacement to the whole Docker engine. Doesn't do anything different, or it's a compactor. It's options that you have in the market, Podman, for instance. It allows you to run rootless, which some people like. They take that from Canino. It's just something that the Docker team is building compared to Canino and other options built by other teams.
So is it compatible even with Docker inside Docker?
Yeah. You can build Docker in Docker.
Cool. Any other questions?
Is it coming to
Shall we
Windows?
put it on the microphone so people back home can hear you?
Is it coming to Windows?
Eventually. That's all I can. That's all I know. There's people working on it, but there's no major progress done so far. But eventually, yes. Sorry, can you say again?
Compared to Kaneko.
Hmm?
Kaneko.
Yeah, Kaneko, yeah.
Is it similar?
Yeah. It's an engine. It's just built from the ground up to be modern.
Anyone else has a question while I'm in the back? No?
Thank you, everyone.
Cool. We'll give it another round of applause. So we do have a little bit longer for the Christmas raffle. So does everybody have their raffle tickets? Yes. So can I ask Brian and or Vicky to come to the front? Where is Brian and Brian? Hi. We're going to do the raffle. Do you have the raffle tickets?
Vicky has the raffle tickets.
Raffle tickets. Okay. So I'm just gonna switch to this mic. Right. So we have a hat. I mean, if you
Talk amongst yourself.
really want to go to the toilet and go and grab a drink and
Yeah.
come right back, then
It might,
it
yeah,
might be useful.
that would be great.
So, 5 break. And then we'll have another break after the raffle, by the way.
That's
Any
mine.
other Technomians come and help?
Yeah.
Did we actually give away all of them?
No, so what number did we go up to?
Well, it'll be up to the pages. Up to the rip.
No, but did you give away all of them?
Up to the rip, yeah.
Okay.
Yeah, so this is the last. Back off, guys.
And push those out. So you should be able to access the layer before the one that failed.
So many
Access
beers.
that manually and you can
People are not drinking enough beer.
Yeah.
But the thing is,
So, that's mine.
Well, who's choosing the dog? Who's your special guest? Well, I'm not going to leave them here.
Yeah.
I'll probably take them back to.
only when it's finished and filled,
Wait.
and pushes the metadata through. So if you look at the metadata, you have access to the layers. You can push the layers, but you have to manually push the metadata first, which is easy. You have to build access.
Normally, Gus doesn't really care as long as it's like alcohol for them.
Well, like, it's going to benefit Technomian. We'll obviously get Dommy involved, and we need more. I don't. Well, yeah.
Or the easier way, just go.
Hello. You behaving? Yeah, I've had that.
Go all the way, and slide through.
Yeah. I've looked at the YouTube.
Too fast.
Sit down. Please, and thank you. Sometimes I forget I'm in England, and like British politeness is a thing. Alright, without further ado, I would like to give the stage to Victor, who's doing a talk about MTLS and stuff like that. Round of applause, please.
Hi everybody, I'm speaking about MTLS and stuff.
And stuff.
So, yeah, just a clear minor correction. If you were trying to look at my Twitter account beforehand, there was a slight typo in the meetup link that was finished today.
Sorry.
But yeah,
Yesterday.
it's all good. It's all good. But yeah, it should be up there now, and you can see it in the footer here. So no big deal. So today, I'm going to talk a little bit about MTLS, which is, as you'll see, pretty big deal these days, and a lot of people don't tend to know what's actually going on behind the scenes. So I'm going to talk a little bit about an overview about that, how that works, and so on. Then I'm going to dive into a demo, and all praise the mighty demo gods. We've seen them have been very nice this evening. So let's see how that goes, and then I'm going to recap of that. So this is really not as complex as the Calico demo. We're talking more about a demo to understand the concepts, more so than going into something that's production ready. So this is more, because it is more proof of concept, right? So this is by no means a replacement for something like Istio or Calico. But it serves as a good example of how the concept works. So, who am I? My name is Victor Peterson. I've done a few startups, and my company previous to the company I'm at right now called Screenly. We do digital signage on Raspberry Pis, power about 20,000 screens around the world. One of our powers is actually security, so I've spent a lot in security and understanding security in general. And my current company is Watt, and we do service security and helping people with DevSecOps and ensuring that your workloads are actually secure. But just real brief, so Watt is a developer tool and helps secure workloads, and it gives you cryptographic ID, and that's an XO5 and an X509 certificate, and that's important in this talk because we got to use it, but you could use any other TLS or roll your own PKI. We have a dashboard that integrates with GitHub and so on, but I'm not going to waste time on a vendor spiel here. But let's go on to the scenario that we're going to do here. So we have this workload, we have this client, and that could be a container, that could be a VM, it could be anything really. It's something that needs to talk to our API, and the API is we're going to demo today in this end-to-end solution. And the important part here is that we will not be using username and passwords. And that's kind of a fundamental concept in MTLS, or mutual TLS, that we're going to use certificates as a replacement for credentials. And there are some really important reasons why that is. For instance, it vastly simplifies how you do rotation, because it's a cryptographically signed, so you can actually rotate this much more easily than you could do with credentials, because they have expiration and so on. But we'll dive into that a little bit later. So the scenario is this. We have some kind of client, as we spoke about. That could be a container. In this case, in the demo, we're going to use a container, but that could be really a VM, a container, bare metal. Doesn't really matter. Then we're going to route that into an Nginx box. So we're going to use an Nginx Docker container, and then behind this Nginx Docker container, we reverse proxy onto our app server. And our app server in this case is going to be a very simple Django app. And we're going to really be using the power of Nginx here to offload some of the power, offload some of the workload we otherwise have to roll ourselves. So that's what we got to do. And before we dive into the details of this, let's take a step back and talk a little bit about the concept. Because I think when you dive into Istio and things like that, you kind of need to take a step back and first of all understand the underlying technologies. So let's talk a little bit about TLS versus MTLS, or mutual TLS. Let's talk a little bit about zero trust networking and versus traditional perimeter-based security. And let's also talk a little about PKIs and the root of trust. So, you're all familiar with this because you use this every day, even if you don't actually are familiar with it. This is how your browser talks to whatever endpoint you're using, right? In regular TLS, the client verifies the server, but that's as far as it goes. There are a lot of checks and balances in there, but essentially that's where it ends. Now, with mutual TLS, we add the new layer to this on top of that. So not only does the client verify the server, but the server also verifies the client. And because of that, we can create access policy around this. And that's the cornerstone in zero trust networking. And that's why X5 certificates and MTLS is such a cornerstone concept in zero trust networking. So going forward a little bit into perimeter-based security versus zero trust networking, or zero trust at large. And perimeter-based security is perimeter-based security is essentially the traditional 90s style network. You put a firewall around, you buy some fancy firewalls, so you put them around your infrastructure, and then you hope you're secure. Because who could possibly breach that? Well, as it turns out, once you breach the moat or the perimeter, you can do whatever you want. And that's kind of the concept that zero trust networking is trying to address. Assume that everything that goes on the network, even if it's within the network, is hostile. And if you assume everything is hostile and you act accordingly, now your security is so much higher than it would be otherwise. So encrypt and verify everything, even if that's within the perimeter, so to speak. And the most common examples of zero trust networking would be Istio in the open source world, and that comes from BeyondCorp from Google, which is an internal Google concept, but Istio is an open source implementation of that. There are others, but I'm not going to dive into that too much, just to give you a quick overview of what the concepts are. And again, I can also recommend the Zero Trust Networking book that Karthik recommended. It's a really good read if you're interested in this concept. It covers the foundational pieces in here much more in depth than I can go through this talk. So I certainly recommend that you read that book if you're interested in this concept. And then a quick brief overview on PKI. Again, PKI is something that we deal with every day. We use certificates every day, even if you're not aware of it. But it is essentially how you verify trust on the internet at large. And usually this is done through a public CA, like Let's Encrypt most commonly these days, but you have other traditional, like Komodo and these guys that are selling you certificates. But that's essentially where the root of trust originates. So the root of trust is in the CA, and you can roll your own. You can roll your own CA, and that's sometimes preferable if you're using it internally. But obviously, your browser would not accept a self-signed certificate. But for use case of zero trust, that is a very valid use case of a self-rolled, self-managed PKI. And while zero trust networking and Istio and getting all that hype, there is a recent development around MTLS that is really interesting. So there's an RFC out there right now that is actively being worked on, which is currently in a draft that is zero trust, well, using the same technology, not fully, but part of the MTLS part, for OAuth. So that means that you can use this in a regular OAuth or like web-like framework. So instead of sharing an OAuth key and secret and token, you would instead use a certificate. So this is being worked on right now, and we'll see if it actually becomes a common standard, but it's a really interesting concept of actually using MTLS for identity for other types of workload outside of zero trust. All right, so in today's goal for the demo is to use MTLS for the transport layer, as we discussed here. We're gonna rotate keys periodically, and this is one of the strengths with using PKI. And if using something again like Istio, I believe the default in Istio is that you rotate the keys every hour. Now, that is not very usable if you're operating on a bigger scale outside a cluster, but in a cluster you can have very short lifetime of these certificates, and the big benefit of having a short lifetime is that if a certificate were to get compromised, well, your attack vector really, or your attack length of that is very small. So if you have if your certificate is an hour long and that's compromised, well, after an hour that certificate is useless anyway, you can't really use it. But outside of a cluster, you probably need to have a longer time period. In our platform, for instance, we use 7 days, which we felt like a decent balancing act, but it depends again on the use case. You'd have to tweak that for that. But the bottom line is that it's a core concept in zero trust and in this kind of in this line of thinking that you use a short-term certificate. You don't do a 1 year or 2 year certificate. You do like days, hours, or months certificates. So we will then use this as identity for the device or the endpoint we're talking to, and then as a result, we don't need to have API keys or use no password. Now, diving in a bit to the infrastructure here, so I'm going to prepare the demo, and the demo will be using a small VM on GCE. We have a Docker Compose environment that we're setting up, an NGINX server, and a small app server. We also have an Nginx server with a Let's Encrypt certificate, that's reverse proxying in, and again, we'd be dog feeding the what here because we get a free certificate there, so it's easier for get up and running here. And zooming in a little bit more on the app, again, it's a Python app, and we use the HTTP headers that Nginx is sending us to as access control. And do note, however, this is very much POC, and there are no attack vectors, so don't use this, even if there is a repository of this working, don't use it in production, because it's definitely not designed for this. Now, let's look at the access control, how this works. So, on the very left here, you see the ingress that is flowing into your Nginx controller, an Nginx container. The Nginx controller will then verify that the client has a certificate, or submitted a certificate rather. So if it's not using MTLS and doesn't submit a certificate, Nginx will not even pass it on to the behind the next server. So we'll shut it off right there. If it has a certificate, you then verify that against the CA. I'll show you in a second how that looks like. And only then will it pass on the request to the actual app server. Now, if you reach the app server, we'll check if that actually double check that it actually received the certificate, so we didn't fail some check there, and then we'll check that against the whitelist, and we'll go through this a little bit. And the deployment of the app is very simple. I'm not sure it's readable back there, but essentially we have 3 services. We have Postgres server, we have Nginx, and then we have our app server. So nothing fancy really, just a simple Docker Compose setup. So let me spin that up real quick. So I'm going to pop over here to a shell. So again, I have this server running. See, yeah, you can read that one, right? Is that readable from the back, by the way? Yes? Cool. All right, so I have my Docker Compose file in here, so I will just do a compose up, and that should fire up the Nginx server. Cool, so now we have it up and running, and now let's see what happens if we curl this. So we're going to curl the API endpoint, which is what we actually use access control for. But let's fire off a regular curl from my local machine here without providing a certificate and see what happens. So we got a 403, meaning that Nginx rejected that right away. So going back then to this here, so we see that we curled here and they rejected it right away. And that's awesome, right? So that means that you cannot really get past Nginx if you don't provide a valid certificate. So that significantly improves the security of our server. So Nginx blocks it, and now let's revisit the flowchart. The flowchart really looks like this. We reach Nginx. Nginx then checked if there was a certificate. There was no certificate, and it simply sends it for a 3. Cool, so that's awesome, right? But what actually happened behind the scenes here? Well, if we dive into our Nginx config, I'm not sure, is this readable from the back? This is a smaller font, right? Okay, cool. Okay, good. So, on the very top here, we can tell Nginx, on the very top block here, we can tell Nginx that we want to verify the certificates comes in against this CA. So this is the CA for what again? You can roll your own certificate and so on, but you would have a CA regardless. So this certificate, the CA, we want to verify against cryptographically then. Then again, if we zoom into the API endpoint here, you see these 2 lines on the bottom, and those will take data that Nginx processes and send to the backstream server. But because we never really got that far, Nginx rejected right away, because if you look at this line right here, if there's no client certificate, then just terminate, reject the connection right away. So we never even got the app server, right? So that's how it works. So it's very neat. Like literally, you need 3 lines to do this, or 4 if you include the if statement in Nginx config. Everything else is really built in. So it's super neat, super easy way of actually getting this up and running without much work. So I'm going to do demo now and show how this simple little app server works. So all praise the demo gods. Cheers to that. We'll see if it actually works. And so again, I'm going to show this real quick. I'm not going to bother showing the browser, but essentially this is the WAF dashboard. This is an agent you install. When you install that agent, you automatically get an X5 certificate. That's what we're going to use today in the demo for the sake of time. But you could again roll your own certificate, CA, PKI yourself. Doesn't really matter. We're just going to use this now for speeding things up. So I'm gonna now spin up a. There we go. All right. So I have now gonna spin up a Docker container here using Debian Stretch that we're gonna use as our server that we're gonna communicate with the backend with. And I'm gonna now install the what agent. Oops. Sorry about that. I need sudo for this. Oh, sorry. Okay, it's not the demo, guys. It's me. Let's see here. I should have done this before. Silly me. Well, the internet is pretty fast. We are at Cloudflare after all, so I would hope they have good internet, right? And I'm going to install jQuery sudo real quick because I can't sudo when I install sudo. That would be hard. Cool. All right, so now I'm just going to pop this in real quick, and boom. Now I'm actually installing the agent. This shouldn't take many moments. Apologize for those guys who caught the curl to sudo bash, but we'll work on that. But I know that's the kind of puffle. But we are now very close to installing. There we go. And bear with me for a second. Almost there. And are we? Yeah, we are. We're close. I can feel it. One package left, I think. Yeah, we're almost there, guys. I didn't want to prepare this ahead of time because it would kind of take away of the experience of setting this up, but
Layers.
well, I guess you could have done it in layers, that's true. I could install the dependencies ahead of time, I guess. All right, let's move fast now. We're almost there. Come on now. Lots of Python dependencies. All right, I think this is the last package. I know. All right, done. All right, cool. So it's now installed. Okay, let's verify this with what? And
You don't need to because you're already root.
this is very true. I do not need sudo run root. It's just a good habit, I guess. But this is my cryptographic identity that I received from what, and that's what the certificate is signed for. If we know now, go back in the demo.
That's a public key?
It's signed from our CA, so it's a self-signed certificate. It's not a public CA, but it's signed from our CA.
What are you seeing there? It's a public.
It's a public key. Yeah. Well, actually, it's actually the CNAME for not CNAME. It's the common name for the certificate that we show. So, but yes, good point. Now, if we try to curl this one instead, let's take this command here and see what happens. So if I try to curl using, if I now try to curl from this container that I was just in, let's see what happens. Again, I don't need the sudo, but I'm just going to do it anyways. Okay, well this is a different error, right? This is not what we had before. Cool, so that means that something changed. So, you shall not pass. So, what happened? Let's go back to our flowchart. If we go back to our flowchart now, you will see the following. We got to the end. However, we were not in the whitelist. So, instead of being rejected from the Nginx container, we get now rejected from the app server. So we made it all the way here. Cool. That's awesome. Because we can skip this step because if we got there, unless we bypass all the way, we would never have to get here. In any case, let's take a look at the code base for what got this magic happening. I'm not sure this is readable. I hope it is. Again, the very first check up there is the same we had in Nginx before, so it's basically to double check that, make sure we actually got a certificate and the certificate is valid. And the very next step here, we check if that certificate that Nginx gave us verifies and is in our whitelist. So what is this whitelist I keep referring to? Well, again, I already did this, so I know what SSI. I know what my hostname is for the device, so let's pop into our Django app, which is our app server again, and enroll the device that we want to use. So I'm going back here, and I now will see this is my ID here. So I will now go into the admin interface. Oh, sorry. All right. I will try to do it on this screen. Yes. So this is basically a Django admin app interface. Super simple here. It's a proof of concept again. Nothing production ready. But if I go in here and add the device to the whitelist, I can now add node, and I can enter this that we got from the device. And if I say, oh, Dr. London, and I calculate things properly, and if I do this now, cool. And if we're lucky, if we do the request again, I shall not pass. Okay, well, that's strange. Did I type it wrong?
Yeah, you didn't enable.
Very good point. Very good point. Again, live demos, they're fun, huh? Okay, so now it's enabled. And save. And if I now go, boom! It worked! Yay! Cool. So this is what I got, right? So we curl the things. We got in. Yay. And again, revisiting flowchart. We got all the way here. We got the request. That's pretty awesome, right? So that is more or less the end of the talk. In conclusion, MTLS does not have to be scary. I hope this gave some kind of at least better understanding on how the concept behind MTLS and concept behind Zero Trust Networking works at large. It is easier in many ways than using credentials, and it gives you a lot of security benefits, such as credential rotation built in. And again, it is the foundation for Zero Trust Networking. If you want to get in touch with me, please drop me a line or ping me on Twitter. Or I also recommend that you visit these sources. I'll put these slides up afterwards. I presume Dom will tweet them out. And with that, I guess the real question is, where's the bar?
Where's the bar?
Well, I guess we have any questions there.
So before we head off and make sure our liquors are happy with the intake of liquids, are there any questions?
Yes.
I'm going to get you in a moment. You always have questions.
So on one of the slides you said this is an alternative to passwords.
Yeah.
But it seems like you're only dealing with situations where you're authenticating a system to another system where you control both ends of this.
Yeah.
So it's not useful for authenticating users of those systems. Is that correct? So you'd still have passwords or some other authentication mechanism for the user of that system, even if it had a certificate, even if you had a client certificate?
So that's a very good question. So in theory, you could use this. And so if you're looking at something like Google's Beyond Core, they use it in their browser. The reason why it's difficult to use in the browser is because unless the browser trusts the CA, it will reject that where it's making the call to, right? So it is possible to use this within the browser, but you basically would have to rely on extensions to the browser. I think Google got their own fork of Chrome, presumably, where they bake this stuff into their Chrome browser. But you could use it in the browser. It definitely works in other environments like mobile as well, but it is not as readily available as, say, credentials. But think of it more as a ready way of replacing API keys already, where you use them in a more programmatic fashion, not like an end-user way. Cool.
Cool. Anyone else on this side before I run all the way that way? Any other questions?
You want to ask a question?
So picking up on that question,
Yes.
how do you distribute securely the process of generating the certs
to actually get up like this?
Yeah, so that's a very good question. So there are multiple ways of doing that. The way we do it in the WAP agent is that the device, when you install the agent, and this happened when we did this actually, the key actually never leaves the device. Only the CSR leaves the device. So the key never leaves that. So that's how you secure it essentially, and it generates a random ID every time. Well, not every time, but every time it bootstraps, it generates a random ID. There are other ways you can do it. If you roll your own PKI, you have other ways of doing it, obviously. Then you can, I mean, if you're running a PKI internally within the company, then you would probably hand the keys out. But you could do with CSR, or you can hand out the keys. It depends on your use case. Right?
Any more questions? All right, well, I think that concludes it. Can we give a round of applause to the Before we run off, can I ask you two things? Please make sure all of your trash is in a trash bag or in a recycle thing, because we don't have any Cloudflare people here helping us cleaning up. And the second thing is, we're going to Allbar 1. Follow anyone at Technovo to the bar. Thank you for coming, everybody. Have a lovely evening.
I do indeed, yeah. Tjena! Jo, det är inte varje gång man har svenska.